Now this problem here is far more interesting. I'll show you one way that I did this. Is there a faster way of doing this problem than the way that I'm about to show you? Maybe, but what I'm about to propose to you is 100% valid. So right off the bat, let me hit this with the idea of turning something from log form into exponential form. Now from here, if you look only at the left-hand side, which looks like this here, let me rewrite this, which looks like that, into this. Item number 4 is called the change of base formula. Let me apply the change of base only to the left-hand side. Now on the right-hand side, let me apply, I suppose, also the change of base formula, which gives us log W over log 2. Now, in the top left here, which looks like this, let me apply this expansion property. And in the denominator, let me apply this expansion property, and I'll leave this as is. Now, in order to make matters more attainable, let me make a use substitution. I am going to let x equal log w. And I am doing this so that it doesn't hurt my eyes because there's so much writing going on. I think we can write this simpler so that it's easier for our eyes to look at. So let's rewrite this, but instead of log w's, we'll just use x's instead. So the overall goal is to solve for w. But for now, temporarily, I really want to solve for x. And once we know x, we can plug it in here and solve for w, the overall agenda. Now, what if we cross multiply? So a cross product gives us this times that, which is here, and then equals, and then we have that times that, which is there. Now let's apply the distributive property to both sides. Okay, now let me subtract x log 2 from both sides of this equation. And of course, here on the left, these eliminate, but these are actually like terms. So we get back the following. Now let me take this and let me write it upstairs. So now let me subtract this term to the other side to create a 0. Let's see, so x squared is there. I mixed and matched these pieces, that's totally fine. I put that on this side so it's negative. Now let me do a couple of things here. So 8 is the same as 2 cubed. So now what I'm gonna do is I'm gonna take this 3 and I'm gonna put it there. But you know what, to be honest, I can actually take the 3 and just put it there. So it'll be a 3 here, and then it'll be log 2 times log 2, which is log 2 quantity squared. So here is what I have. And notice that I did what I did to get this to look like a quadratic equation. And notice here that 1 is A, and this number here is B, and all of this here is C. So I choose to solve this quadratic equation with the quadratic formula, although there are other ways. But now let's set up the quadratic formula. So we have negative and then b plus or minus the square root. That's b squared minus 4 times a, and that's c all over 2a. And let's see, that double negative is going to become positive. When you square the negative 2, it becomes positive 4, and that'll be log 2 squared. That negative is positive. 4 times 3 is 12, and the bottom is just 2. So let's make these changes. And so we have here 4 of these plus 12 of the same thingy. 4 and 12 makes 16 copies of that item. And this is so convenient because we can square root the 16 to get 4, and we can square root that square to make that piece go away. So here's what we have. And notice that these are actually like terms, where we can go 2 log 2 plus this, and then 2 log 2 minus this. So we really have two values of x. And then we can actually simplify both of these little values of x. And then we can divide these coefficients. So we have found the two values of x. But recall that the overall agenda was to solve for w. But we're almost done because you can take these values of x and drop them off one at a time in here into the red equation to find w. So here is what we get. So let's see. So I took 3 log 2, which is x, and I put it there on the left-hand side, which is here. And on the right-hand side, we have log w. I did the same thing on this side. So now let's take this 3 and bring it upstairs. And then notice that it's just log and log. So the logs can knock out, and it's just 2 cubed equals w. And here also these knock out. So it's just that equals w. And so we have our final answers of w, 8 1/2. And both of these do in fact satisfy the original equation.